All right, so the next section in our textbook is all about the states of matter. And we're going to start off by talking about the observed properties of matter, and some of these will just be review. So one of the properties we could measure is density. You can do this for solids, liquids, and gases, but it's pretty easy. If you remember, it's just the mass of something divided by the volume. So for example, a lead ball is going to have really high density compared to an equal volume of styrofoam. It's something we encounter pretty regularly in our day-to-day life, but we can do this for every state of matter, solid, liquid, or gas. So that's one of them. The next one is shape. So we can look at the shape of various things, whether it's a solid, a liquid, or a gas, but it really depends on the state of matter. So for example, if you've got a solid, it will have a defined shape. However, a liquid will have an undefined shape. And if you have a gas, it'll fill a container, meaning a really undefined state. So it depends on state of matter. Okay, and then the next one we can look at is compressibility. And compressibility basically means how much force does it take to squeeze something. So it is the change in volume resulting from pressure applied. So for example, a solid is a lot harder to compress than a gas. A gas, we could put pressure into some sort of closed system and actually squeeze that gas down so that it takes up a smaller volume. All right, the last one is thermal expansion. And thermal expansion is basically measuring the change in volume resulting from a temperature change. So it's a little bit different than compressibility because it's dealing with just temperature being applied, not an external force. All right, so all of these are pretty important. I did want to really go back and hit one point though. So down here, we said that we get a change in volume resulting from a change in temp. But up here, we were measuring volume. So normally, we should give the temperature when we're listing density. It's something I haven't really been stressing too much because normally when you're referring to density, you're referring to, standard room temperature. However, if you're at a really cold temperature, the volume might be different, right? Thereby changing your density. Same thing if you're at a really high temperature. So typically with density, you also want to have a temperature value along with it. That way you're giving a really well-defined measurement, one that can be reproduced over and over and over again. All right, so let's go ahead and take a look at this chart from your book. And this chart kind of takes a look at all of these properties and kind of compares them across solids, liquids, and gases. So let's zoom in on this. This is table 6.1. And over here, we've got our solids. So if we think about a solid, it's going to have a pretty high density compared to a liquid or a gas, right? A liquid, on the other hand, is going to be high, but it's going to be lower than a solid. And a gas has a really low density. So gases tend to float above solids, right? You're not going to have a solid just kind of spring up into the air and float on a gas. That just doesn't really happen. All right, so that's a good one to look at. Next one is shape. So down here we've got shape, and if we look at solids, we said that solids have a definite shape. Liquids take the shape of the container, and gases fill an entire container, not just the bottom of a container. So that's a good comparison. And then compressibility, we said that solids, we really can't squeeze solids down to a smaller volume very easily. Liquids, kind of the same thing. We can't squeeze them down very well. However, gas, absolutely. We can squeeze down gases. That's the whole idea behind pressurized cylinders. So if you're in a hospital, you might see oxygen tanks, for example, where it's compressed oxygen. All right, and then the last one, thermal expansion. Solids typically don't have very much expansion with heat, a little bit, but not a ton. Liquids, same thing, they have pretty small expansion, but gases, on the other hand, will expand a fair amount if heat supplied. And in fact, that's the whole idea behind a hot air balloon, is if you heat up the gas, meaning just the air in the balloon, then it will expand and expand, thereby being less dense than the surrounding air, and that force can be used to lift a balloon up in the air. So I know a lot of this seems pretty basic, but let's go through and do a sample calculation with density. And this is just good review. Really, we're just going to be doing a lot of unit conversions when we're dealing with density. And we said that density is going to be equal to mass over volume, right? Okay, so here's the question I've got for you. We've got an iron ball, and it has a mass that is equal to 1672 grams, and it's got a volume of, let's see, 212.3 centimeters cubed. And if you remember, centimeters cubed is interchangeable with milliliters. You normally see centimeters cubed for solids and milliliters for liquids, but they're the exact same value, and we can flip-flop them if we want. All right, so this iron ball is going to be put into mercury. And mercury is liquid, and its elemental symbol is Hg. And if we think about mercury, this mercury that we're putting it into has a mass that is equal to 255,600 grams. So a pretty large mass of mercury. It's just sitting in a beaker, and it's got a volume that is equal to 18886 milliliters. Again, we're measuring this in milliliters because it's a liquid. So now my question is, will this float? And this always makes me think of Monty Python. I don't know if anybody's seen that, but they ask somebody what will float in water, and somebody says very small rocks. Not really. We actually have to do the density calculation for this. We can't just say that very small things will float. All right, so let's go ahead and do the density for this. Okay, so on the left-hand side, I'm going to do iron. And on the right-hand side, I'll do mercury. Okay, and we know that the mass needs to be divided by the volume. So we can go ahead and say, well, this would be 1672 grams divided by 212.3 cubic centimeters. And we can get our value, but let's go ahead and do the math last. Over here, we'll do mercury. We'll say the mass divided by the volume is going to be equal to 255,600 grams over 18886 milliliters. Okay, so let's plug each of these into our calculator and figure out which one's larger, and from that we should be able to determine which one can float. Okay, so 1672 divided by 212.3, and our final answer should have 4 significant figures. So I'm getting 7.875. However, we've got a 6 following, so I'm going to round this 5 all the way up to a 6. So now we've got our 4 sig figs, and this would be grams over centimeters cubed. Like I said, centimeter cubed and milliliters are equivalent. One's just typically used for solids, the other's used for liquids. Okay, mercury on the other hand, we've got 755,600 divided by 18886, and our final answer in this case should have 4 sig figs, just like before, and this is giving me 13.53 grams per milliliter. So we can look at this and we can say that this is more dense, which means that this iron will float. And it's weird to think about an iron ball floating on a liquid, but just because something's a liquid doesn't mean that it's always less dense than a solid, and this is a good example of that. In fact, I pulled up a picture of what this would look like. So here we've got an iron ball, or actually iron square, and in here we've got our liquid mercury. So it is important, if you are given these, to always do the math. Try to prove it to yourself, because in this chart up here, these are just general guidelines, meaning they are not always true. Okay, so if you're working with density, make sure that you go through, do the calculations on your own. And then also try to remember that you can solve for other variables. So you can solve one variable if you have the other two. So if you need to turn this into an algebra problem, solve what you need to solve, but it should be pretty basic algebra. Just trust your math, try to work it out on paper, don't try to do it in your head, and then compare and contrast your calculated values. All right, I hope that helps, but let me know if you have any questions.